Hi, this video is talking about reading Z tables or Z score tables. Um, these are given to you in your exam, so it's well worth knowing how to do it. So Z tables are all about trying to have all those different models with all the possible proportions of the standard deviation to 3 decimal places. So we've got 3 Z scores here, 0.4, which means 0.4 of a standard deviation above. 1.12 is 1.12 standard deviations above, and obviously 0.973 is that proportion above as well. So the key thing to keep in mind is that this column is the first standard deviation, the first decimal. This row is the second, and the differences here are the third decimal point. The other thing to keep in mind is that this is talking about from the mean to wherever the Z value is. Now, because a normal distribution graph is symmetrical, you can use the same value that you get for positive Z, you can use for negative Z as well. So for instance, whatever answer we get for 0.4, you can use for also negative 0.4. And it is relatively easy. So 0.4 to start with is that we just use the column. So we go down to 0.4, and then the next thing is we would have a second decimal would be 0. So that means it would be there. So we end up with 0.4 being equal to 0.1554. Now 1.12, so the first thing is find the line for 1.1, and then we go along the row to 2, which give us that value, which is equal to 0.3686. The last one is always the tricky one when there's 3 decimal places. So first thing is we look for is 0.9, and 0.97 would be that one. Where the third decimal places comes in with these numbers, we know it's 3, so we're going to use that column, and we can see it's 8. So what we have to do is add 8 on to the end, or in the last column. So that would be 0.3348. Obviously that's relatively important, because if we think about what that means is that the difference between 0.97 and 0.973 is that 0.973 is slightly bigger. In fact, it's 8 10,000th of the probability there. Obviously, it gets slightly more complicated when you have to add, say, 20 or 23. Okay, so take for instance, if it's 0.973, 979, you have to add 23 on. So what you would do is you would add the 3 on to the 0 and the 2 onto the 4, which would give us 0.3363. It's very rare to get one that's exactly 3 decimals, but it can happen. And that's basically it. So you now have a table that for any proportion of the standard deviation, once you've changed your x value to a z value, you should then be able to find that area between the mean and the standard deviation. And your z value. So what you need to do now is that there is a task for you to complete. Is that I've got some z values if you would like to get the table. So there's a table located in the back of your workbook. If you don't have that in the lesson sheet, I've also put a PDF of a table that you could use. Have a go at these values and see if you can get an answer. So pause the video, go through in your book and see if you can get the z values for these, and then we'll go through the answers. Hopefully you've gone through the answers, you've written your answers down and we can have a look. So these are the z values for all of these. Always an interesting, what does z equal 4 means? It means it's that 4 standard deviation. And as you can see, 4 standard deviations isn't even on the table. And that's because the difference between 0.49999 is so small that it's insignificant. Okay, so now that you've done that, go back to the lesson page and complete the tasks on there.